Hello everyone, my name is Dana MacCormick, and on behalf of my colleague Dr. Loutfouz Zaman, I'm going to be presenting our work called ECHO, Analyzing Gameplay Sessions by Reconstructing Them from Recorded Data. So to begin with, let's talk a little bit about evaluating games. So by nature, games are a very iterative process. We bring participants in, they play the games, and we use their feedback to make the game better, and then we kind of repeat that cycle. And when we bring participants in, it's called a playtest. During playtests, we often record their screens to generate video footage that we can analyze later to kind of really make sure we didn't miss anything. And this can be very useful, but at the same time can be very cumbersome, since you can only watch one video at a time. Recently there's been a lot of research into the area of game analytics. And game analytics are great because they're very fast. You're able to show a lot of data really quickly, but in doing so, you often abstract away the game to a different form. And so the game can take the form of just a series of data points now. And so in doing so, you lose a lot of the game context that helps inform why players made the decisions that they did. And so in doing so, you're sort of trading off speed for context. You can sort of see that here. So on the left side, we have a great tool called playtracer. And so this abstracts the game into a series of graphs of nodes, which is very great and shows a lot of data very quickly, but you, of course, lose what the game originally looked like. And then on the other end of the spectrum, something very similar to video footage, actually, is Fortnite's, the commercial game, replay system. And using this tool, you're able to analyze Fortnite matches very, very well because you have all of the original effects, graphics, and so on. But in doing so, you kind of lose a lot of that speed. And then we have something in the middle, like player viz here, where you get some of the game context, like these primitives representing a bit of the level, as well as the analytics overlaid on top. And so what we want to do with this work is we want to try to find a better way to bring both the speed and the context together and sort of marry the best of the game analytics and the video footage. In doing so, we developed a tool called ECHO. And so with ECHO, we are using the game's original graphics. So this is a car racing game, but we're reconstructing it from the recorded data. And so while doing so, we're able to actually interact with the data, view it from any angle, and kind of speed it up and slow it down as we see fit. And so ECHO has two primary components. It's got the recording system and the visualization system, with the log files as sort of an in-between. And we had three main focuses when developing the tool. We wanted to focus on interactivity, efficiency, and game context. So again, we've been looking to try to provide a balance of speed and context, but also allow the data to be interacted with so you can kind of customize the viewing to make it easier to understand what's going on. And so we can sort of see that in action here. Right now we're viewing the player's original camera, but through ECHO. And so we're able to speed it up, and we're also able to show actually a bunch of other planes at the same time as well. So previously we just had the one plane, but now we have multiple players together. And while also doing so, we're able to change the camera and view it from a different perspective, and then speed it up. And so we have all these features of interactivity, while also representing multiple sessions at the same time, using the game's original visuals in order to provide the most context we can. After developing the tool, we of course wanted to perform an evaluation. And so in phase one, we brought 10 participants in, and they played both the plane and the car game, which you've now seen, and generated ECHO log files and video recordings. And these became the input to phase two, where we then brought 16 participants in to analyze both games. They analyzed one using ECHO and then one using video footage, and the counterbalanced, of course. And while they were analyzing, we tasked them with recording interesting observations during the analysis of the game that they were looking at. And so this could be either positive or negative. And this was designed to emulate how in games user research, we often develop a list of key positives and key negatives that can be used by games developers to improve the game going forward. Outside of this requirement, there was no specific workflow that they had to follow, as we left it very open-ended. We noticed three distinct workflows actually come out of that, with the third being the most kind of interesting and sort of the general design for ECHO, which is that the participants started by watching all of the data together, so all of the cars and all of the planes, and then look for extremes or outliers. So like a car that went off course or a plane that crashed into the ground. And then after they identified an outlier, they would hide the remaining data sets and then focus in on the outlier to try to identify what happened. And this is really how we see ECHO being used as kind of like a top-down approach. We also got lots of great feedback in terms of features they liked and didn't like, and then many suggestions on improving the tool going forward. We performed the NASA TLX questionnaire comparison, and the score was significantly higher for video footage than it was for ECHO. Along the individual dimensions, frustration was the only one that was significant, however. We also asked the participants to rate the tools on ease of use, efficiency, likelihood of future use, and overall. And ECHO was significantly higher in all categories, but except for ease of use. The primary limitation is that we compared against video footage, which this was useful for the kind of open-ended nature of the study, But it would be also good to perform a study in comparison against a tool like playtracer or PlayerViz. Additionally, we focused in on a single type of game to try to keep them relatively even. In this case, vehicle racing games. But it'd be useful to see how Echo performs with things like first-person shooters or puzzle games or fighting games, all sorts of different games. And then, of course, we can continue to improve Echo based on the suggestions we received. So, in conclusion, we developed a tool called Echo in an effort to try to bridge the gap between game analytics and video footage analysis. In doing so, we wanted to try to bring the speed that analytics provides while also keeping the game context in the way that video footage does. We received a lot of very promising feedback from participants, and which shows that Echo has a lot of potential, but there's still lots of room to expand and improve on the tool in the future. Thank you very much for listening.